In this project, we were working with the company Teco 2030 on the assembly of fuel cell stacks. The project was conducted by a master student on industrial engineering, Mustafa Kazmi. The factory is located in Narvik in Norway. And this is the product that is planned for this factory, a stack of fuel cells to be used in fuel cell modules that is producing power from hydrogen fuel. The student was first conducting value stream mapping of the planned production line using the value stream methodology, setting up process steps using planned processing times and simulating a flow of material through this line. And that gives information on inventory levels and the total lead time of material going through the processing line. The forecast on the output of number of stacks is shown here. And based on these numbers, you would get the customer required takt time for each year. So starting then in 2025 on a planned takt time of 45 minutes. So using that takt time as the roof of the output, so each 45th minute a fuel cell stack is required through the available production time, and comparing this to the processing steps planned for this production line, you would see here that the processing times are not evenly balanced, so there is a variation for one such production line. And also then there is planned one operator doing the pre-assembly, one operator doing the feeding and stacking process, and then one operator doing the rest of the processing steps. And then the student tried different operator setups where there was an alternative B with an extra operator for these last most time demanding tasks, so that you would get 4 operators, and a model C where you, instead of designated operators, use a resource pool with 3 operators working flexibly around the activities. And a 4th alternative D, also using a resource pool, but then with 4 operators. So alternative A and C is with 3 operators, and alternative B and D is with 4 operators. And through this simulation there, you see that there is best output for alternative B and D. Both of these have 4 operators. A and C have 3 operators. And there is then a significant increase in the output going from the system with designator operators into using a resource pool. And the reason for this is that you would have much better utilization of the operators when these are working more flexibly. And with these models, you would then be able to meet the forecast demand according to this suggestion. Thank you for watching.